How many of you are Java EE developers? Wow, pretty much all of you. How many of you are using JAX-RS today? I guess you're using, okay, perfect. Pretty much half of you. So this talk is going to be talking about JAX-RS 2.0, which is the next version for JAX-RS, which is the standard way for building RESTful web services in the Java platform. Now in Java EE 6 today, what we have is JAX-RS 1.1. JAX-RS 2.0 is targeted towards Java EE 7, and my goal is to kind of give you an overview of what features are coming in JAX-RS 2.0. Just a legal slide from my employer, because they're all developers, we don't worry about these things. So the part one really is how we got here, basically. Sort of a quick overview, introduction to JAX-RS, because I realize some of you are not using it. So I'll give you a short introduction to JAX-RS. Then I'll talk about the requested features for JAX-RS 2.0, in terms of what was the original scope. A little bit cut down, so I'll talk about what got approved, and finally dig into each of the features, providing you more details about it. So JAX-RS 1.0 or 1.1 is sort of the latest version, is the API for RESTful web services. REST is an architectural style, and it has certain principles. So it says everything on the web, for example. Web is the first-class application for REST architecture, basically. So it says everything on the web, for example, is a resource. Each resource, for example, has a unique ID, and it's uniquely identifiable. It says that resource can be accessed using common set of verbs. Those verbs in terms of internet are predefined, because HTTP is your primary protocol. So those verbs are get, put, post, and delete. Those are sort of your 4 key verbs by which you access the resource. And then all the communication with those resources are really stateless, in the sense there is no state that is stored at the server. If you want to talk stateful, then you have to send the state with your request. And also another principle is about the common representation methods, which is that each state could have multiple representations. By multiple representation means on the web, for example, we think about there is an HTML representation of a page. If you access the resource differently, it could be just a JSON representation. It could be a text representation. So each resource is represented in multiple formats. So let's see how we take those principles, apply them to JAX-RS. Now, a quick introduction. JAX-RS is a POJO-based API. So what that means is a plain old Java object. That means you just say public class name, and you put your properties and getters and setters. That's it. Just very dirt simple POJO class. On the API itself, it's annotation driven. So on the POJO itself, you put an annotation called as @path, saying this resource need to be published at such and such path. So it's purely annotation driven. And I'll show several samples of the API itself. The API itself is a format independence. You put annotations and you define the types or the representation of the resource. That means that this POJO needs to be published at this and this path, but what's the type? HTML, JSON, text, XML, so on and so forth. So you define the types, but that doesn't go in the API itself. It's container independent. That means, yes, it's included in the Java EE platform, but it does not restrict you to take JAX-RS APIs, bundle it with your application, and run it, for example, on plain Tomcat if you need to. So let me show you an example. So look at the black code only to begin with. So it says public class ATM service. Then I have a public balance, take 2 parameters, and it just returns double toString, and get balance probably is doing some more logic somewhere else, and it returns the balance to us. Now I want to expose this class as a resource. So then what I do is I put the annotation called as @path here. So I say this POJO is exposed at @path, and this is the path where it's exposed. /ATM is the fixed part of the resource. Within curly braces, card ID is the variable part of the resource. This is another method in there, public string balance. This is a sub resource published at path/balance. So if you want to invoke this method, then you have to invoke the resource with /ATM/card ID/balance. And if you access this resource using HTTP GET, which is by this annotation, then this method actually gets invoked. What this is also saying is add produces is returning text/plain types. That means the result is going to be a text result. String is a pre-built, Java pre-built type, so we know exactly how it serializes. So it takes care of that. Now we talked about the curly braces. This is a variable part. So this is variable. This is fixed. This is fixed. Now this variable part indicates that this card ID is actually mapped to @path_param card ID. There are two parameters here. So if you invoke the URL with say /ATM, you give your card ID, say 112233, then that 112233 automatically gets mapped to this card ID, or specifically this card parameter, which then is accessible in your business method right over here. Query param is typically your name value pair. So for example, if you invoke the request, say /ATM/112233/balance, then you come into this method, then after /balance, you might say $name equals value. In our case, name being pin and whatever the value is. Now realize this is only a sample. You don't pass your credit card ID in the RESTful URL. That's not the recommended model. All the more you don't pass your pin in the name value pair. It's just a sample, so never do that. So if I have to walk you that, my ATM service is the top level resource. By putting the second path element, I'm saying this is my sub resource. Then I'm using built-in serialization. All I put is add produces clause here, and string is my built-in type for Java. Then I'm using URI parameter injection. In one case is coming from the path, in other cases coming from the name value pair. And I'm also specifying what my HTTP method binding looks like. Now let's take a look at another example wherein I want to invoke this method. So I want to say withdraw. That's a new method that I'm adding to my resource now. And the way I want to call it is whenever the resource is being accessed using HTTP post. So I put HTTP post here. Of course, I define my sub resource. So it's a /ATM/card /withdrawal. Then here I'm saying it consumes text/plain. That means the HTTP post body will have some plain content. So you consume that. My card and pin get mapped here as is. I take string as the type, which is getting from my body. And here I'm saying the return is really money. So money is a POJO. And I'm saying return type is application/JSON by add produces annotation. So I could put consumes, I could produces. That means produces is the one that is being generated by the return type. Consumes is the one that I'm sucking it in my method. And money being a POJO class, I could just put a JAX-B annotation over there, say like XML root element. And the moment I put that annotation in there, using a convention that XML could be automatically and seamlessly transmitted to a JSON format and then transmitted back. So literally just putting XML root element on money, you can do produces application/JSON. Typical question, I'm saying add produces and I'm saying application/JSON. What if I want to produces multiple MIME types representation? So that's called as a content negotiation. Add produces takes a single value or it takes an array of string as well. So for example, in curly braces, I could put multiple MIME types. And then the content the client dictates what content type does it expect back. Okay? And I'll show samples of that. So that's sort of my shortest introduction to JAX-RS 1.0. Now, with that background, there were several features that were requested as part of JAX-RS 2.0. And the way process works is there's the JAX-RS expert group, which are the sort of the luminaries in the RESTful field, vendors, individuals, all of those together. And they propose, these are the typical use cases. Client API is one example. The motivation over there is, JAX-RS today is server-centric. What that means is You take a POJO, you put an annotation, you expose your resource on the server side. You can do all that logic using your plain old servlet, for example, if you want to. But notice the amount of work you will have to do. Parsing the entire request, understanding is get, put, post, delete, then actually overriding those do get, do post, do delete methods. Within that, again, getting the URL, dispatching to the right ID, and then mapping those values, extracting those, mapping to the parameters. So a lot of work would be required. So JAX-RS actually makes it easy by putting annotations and mapping the values. Same concept applies on the client side. So if you have to handcraft your request to the client or to the server today, and not to JAX-RS endpoint, any server, any RESTful server, you will have to handcraft your request. Oh, I'm making you will have to open a Java net URL connection, and then you have to set the type that I want to invoke, get, put, whatever the verb is. Then you have to handcraft your message. This is how my XML is going to look like. Convert it to XML, then put it into your body. So a lot of work would be required. And then when the response comes back, same thing. So the proposal for the client API is really the idea to, say, provide a simplified API using the existing concepts, and then let us invoke a RESTful server very easily. That's my client API. Now, filters and handlers are typically very useful for pre-processing and post-processing request and response. So logging, your aspect-oriented programming, that sort of stuff kind of helps you here. Hypermedia is a very useful use case, which is where you say, okay, I'm getting a response back. In my response, I have a link to another resource which needs to be accessed. So think about in a web page, you see HTML link, you click on it, it goes to the next resource. In terms of programming, there is nobody waiting to click over there. So your program needs to understand that what is your response body. From the response, retrieve the hypermedia or the link, and then do something about it. Hypermedia, today there is support for that in JAX-RS, but hypermedia support will make it much easier once again. Validation is very interesting use case, because you can take your HTML form, for example, today, and you can say, submit this to a JAX-RS endpoint. It's a predefined MIME type. You can automatically start mapping your HTML form fields to a RESTful endpoint. All of that can be very easily done. For validation, that means if you're putting the name field over there, what if somebody put numbers in there? Not that nobody can have number as a name, but the idea is you want to have some sort of validation. Either you'll have to bring your custom code over there, or you'll have to do your custom validation on the server side. Exactly for that, we have bean validation specification already existing, which allows you to define constraints on the bean, which are then honored by different layers of the stack. So a validation would actually add support for that. Excuse me. MVC was discussed pretty heavily, and the idea over there is, you can have any front end, which could be Velocity, HTML, Java server faces, or just a plain jQuery front end. Your JAX-RS, a resource, could be a controller, and model could be a JPA entity, for example. So that was sort of the MVC use case that was being discussed. But it required too many changes in lots of different specifications for it to be successful. So that's where it is right now. I talked about connection negotiation, how from the client you can request what content I want, but there is nothing on the server side which would control that. So that's the feature that we're talking about over there. And in terms of async, the idea is to, your server resources are very costly, or at least they need to be utilized appropriately. So by async, I really mean having a server-side async and a client-side async. Okay, and we'll see samples of each one of these. So with that, let's see. The expert group was formed in 2011, last year, actually March 2011. Oracle is the lead for the JSR, and there are several individual members and big companies which are behind this. And there is an early draft that is already available which talks about all these features. But where we are going in terms of all the features were kind of approved by the expert group, and as I talked about the MVC part of it, it required too many coordination and changes. And then there are other frameworks like JSF which already serves that need to an extent. MVC was kind of considered out of scope for now, at least. All other features, very much part of the JSR. Let's look at some code. So talk about the client API first. So as I started talking about it, the HTTP client libraries are way too low level. You have to do a lot of handcrafting, the HTTP net URL connection. And then in the JAX-RS, we already have the concept of message body readers and message body writers. So you're not just restricted to predefined MIME types. The idea is you can define a custom type. My custom request type. My post body is coming, in that I have a totally independent MIME type. How do I handle that? So that's exactly where your message body readers and writers come in handy, because you define this is the XML that I'm going to get, and I'm going to map it to this MIME type. So that's very much possible. And then another motivation for this API is this support was already provided by several JAX-RS implementations. So with that, that's how our API looks like. The first thing is do new of client. Now, this is sort of an old way of doing things. So maybe you should be able to do, say, add client, just inject the client for me. Somebody else do the factory and all that hard work. So I should be able to just say, add URI for the target, and this should give me the client. That's sort of the proposal. But then the idea is we have a builder pattern. So once you get the client, then you can set the target on it, that this is the resource that I want to invoke. This is my path param, which was sort of my variable part. So here, for example, within ATM, I had my card ID. That card ID could map to this card ID right here. I'm specifying. Now, path param goes in the path. Then I have a query param, which goes as my name value pair. So it goes over here, query param. Then I want to say requesting a text plain. And then I'm getting the response back, which is going to be of the type string, which is what correlates to my this string type right here. So that's how you will kind of structure your request using builder pattern. Because somewhere you have to specify the URI though, right?
So let's say if I pass in after balance, let's say this number.
Say again, so? Yeah.
So I pass this number.
Right.
To URL.
Right.
And it will be interpreted on my JAX-RS side.
Right. Yeah. So the idea would be is, as I'm saying here, this is just one usage of it. What is being discussed, for example, is I should be able to specify the URI, put the within parentheses card ID, and inject my client. So I may inject my client once, and then I may parameterize these things one by one. So yes, if you want to invoke the resource once, you can put everything in the path itself. But what's cleaner? You may be even getting this card ID as a parameter as a method. So what I'm showing is a very simple usage of how client API is going to work. We put some money, check the balance. Now we're going to withdraw the money. Same use case. So client, target, path param, query param. This time I'm requesting application/JSON, and all I'm saying is I'm posting. And remember, our consumes was application or text/plain. So I'm passing $50 here, and I'm saying give me the money back, which correlates to this money right here. So from Java perspective, you're only dealing with the money class, just the POJO class. So everything is done in the Java, but on the wire, what it's saying is application/JSON is going to happen. Now those are sort of what we call as a static usages. You could also have a need wherein you want to batch your invocations, or you don't know exactly how the request is going to look like. So this is a little bit more generic interface. So all you say is client.target, you say request text/plain. This is going to build a GET request for you. Same thing, client.target, request application.json, build post. This is going to be a post request for you. So you can build multiple GETs and posts together, and then you can batch them. Say, just fire it, and it's going to execute it. Now in this case, I'm not going to explain the code, but this is a third-party library really, and all it's doing is invoking the invocation patterns that we built in the last slide, one by one, and processing their response and giving me the response back in my collection of responses. So that's sort of my client API. Okay, let's take a look at the second one. Interceptors and handlers. So these are well-known extension points that allows you to extend your JAX-RS implementation, both on the request side and the response side, both before and after, all the places. So there are all different possible extension points. Several use cases, you want to log it, you want to do gzipping, for example, or you want to do some sort of auditing of your requests, anything of that is possible. Another motivation for this is, again, this was supported in a proprietary way by several implementations. By making it a standard, you make your applications portable. Typical usage of why you want to go with the standard, because it makes your application portable and keeps it clean. So filters are my non-wrapping extension points. So what by non-wrapping I really mean is filters do not alter your request. They're non-wrapping in the sense they take a look at the message and they can dump it down, but they cannot change it in any sense. Okay? You can have multiple filters, and the filters are on the request side and the response side. Okay? You do not call the filter directly. I'll show that in the code. All you do is each filter could independently make a decision whether this filter makes sense, whatever the logic of the filter is. Does it make sense? If not, it can just break the chain wherein none of the filters in the chain actually get executed. Code again. So this is my logging filter. And as you can see, this is one class which is implementing both the request filter and the response filter. Now the request filter actually gives me a method which says pre-filter, which takes a parameter called as filter context, and here it returns a filter action. Filter action is what defines what I need to do, whether I am going to call the next filter in the chain or stop the invocation. In here, all I'm doing is I'm taking the filter context, and filter context allows me to dump my request. So it's a very simple piece of code. All I'm doing is just logging my request right now. I'm not talking about it yet. Compression is coming in the wrapping extension use case. Thank you for leading there. No, why? No, not really. So the idea is. Right, hold on, let me complete. So the way this works is, yes, a servlet is the backend, but that's not something that is exposed to the outside world. So the idea is, you say, okay, this is the URL that is being exposed. You are allowed that URL. So you say, this is sort of my base path for my RESTful resource, and everything from there is going to be a RESTful resource.
Correct. So the question here is, I can define my own filters on that particular servlet or the path. So how that servlet is different from this?
Well, that's a servlet filter. That's just one more way. That's a servlet filter. That's for your servlet itself. Again, the same logic. In that servlet, you don't have access to the request. So for example, you have access to the request, but in a different terminology. All you get is your HTTP stream, and you have to play with the HTTP stream. Here, you actually have a request with you. Then you can play around with the request, and request again would be a standard API. So you have much more granular control over here. Over there is much more coarse, so you have to really extract the details for yourself.
Maybe I can define this at the resource level?
Define what?
At the resource level?
No, but I think those are different use cases. Servlet filters are much more generic. They give you access to servlet body. So you'll have to extract your RESTful resources, etc. over there. These are all defined as, so this logging filter is a provider, and then you have to attach it to the resource anyway. Remember, this is the non-wrapping use case. I'm not modifying the body. The wrapping use case is where I'm going to modify the body, and I'll show you that use case as well. Here I'm saying, filter action, again, same thing, break or move. And this is coming from my response filter, which is the post filter method. I still have filter context, and the same thing, I'm logging a response. I say context.getResponse, I get my response body, and I can log it. Interceptors, on the other hand, are my wrapping extension points. This is where my message body can be modified. Okay? Similar concept though, I have read from interface, and that's exactly the reason where the filters and interceptors were defined independently. That yes, there are use cases where you don't want to modify the body, there are use cases where you do want to modify the body. So these are my wrapping extension points. Similar concept, read from, write to, those two interfaces are there. They're part of our interceptor chain, and here in this case, you're calling the next handler directly or interceptor directly. And let's take a look at the code. So this is my exact example of a gzip interceptor. And again, here I'm implementing both the reader interceptor and the writer interceptor. So in this case, this method name is very ugly, around read from. I don't get that method name. But it says around read from, that's the message. Here I'm getting the read interceptor context. So I'm reading it, so it's on the request side basically. From the context, I have a method which says check whether the message is gzip encoded or not. So it will have some mechanism by which it will scan the message, and if it's not gzip encoded, it's gonna get the stream and change the input stream. This is exactly where you're changing the message itself. And you're saying new gzip input stream from the old. So you're actually changing the message body. So that's why it's a wrapping extension point. And similarly, you will have around write from. So you want to gzip encode or gzip decode. Depending upon that, you will write your interceptor here. Just to get a quick understanding of how the order of execution works. So think about this is where your client is sitting, and think on the far end is where your service endpoint is, which is what your RESTful resource is. So in the order of execution, you always invoke the filter first or handler / interceptor second. And this terminology has changed between early draft 1 and 2. Used to be handler, now is interceptor. So filter, handler, then request filter, read from handler, and coming back again you have filter, handler, filter, handler. So how do you bind it? So you've defined your, say, logging filter, right? When we were talking about that earlier. How do you bind the logging filter? So first of all, you need to define, a boilerplate code saying, okay, this is going to be a name binding. Name binding is a new annotation that they have defined in JAX-RS 2.0, saying that, okay, this is going to be bound to a resource. So I define a name binding, call it an annotation, meta annotation, say logged. Now this is exactly my resource. That's what I was talking about earlier. So public class logging filter. This is implementing the filter. Here, all I say is this is of the type logged. Then on my resource class, this is the method that actually gets invoked. So this is my resource. This is my HTTP GET method. All I say is just log this method. So that's sort of how we expect the logging filters or interceptors, etc., to be associated. You can associate them at a method level, at a resource level. So all of those combinations are possible. And then there are the precedence rules, how they work. All right, let's take a look at validation. Now, as I talked about it, validation is important because once you receive data from a client, you don't know how clean that data is. You should be generous, but you should still be able to validate it. Hey, somebody said it should be only string or it should be only numbers. Are you sending me alphanumeric numbers over there? So that sort of validation is important. Now, as I said, bean validation already provides mechanisms to do that sort of validation in the Java EE 6 stack. So the idea is to leverage that as is and integrate that with the JAX-RS specification. And in terms of validation, there are different positions where you can do the validation. It could be at the fields and properties, at the parameters, the methods, and even at the class layer itself. You could say, validate the whole class as is being mapped from a RESTful resource or response. So let's take a look. This is a resource exposed at the root, invoked when post is being called, and this is a built-in media type. This is a standard media type. So imagine your HTML form being submitted to a RESTful resource. So this is the MIME type that you get over there. You're saying at register, or the method name is register user. So your HTML form apparently had some fields, one of them being first name, last name, and email. So these three are being mapped using add form param. Okay? to these parameters. Now, at not null, those are the standard annotations defined by bean validation. All it means is this field values cannot be null. If they are null, it'll throw an error back to the client. Okay? Well, ideally you should do these validation on the client side, because these validations here are happening on the server side. So you're making an unnecessary trip. But the idea is at least JAX-RS provides that mechanism. Now those are the built-in MIME types. You can also create your custom MIME type very easily, or custom validation type as well. So for example, you could say at email, and you can define your email validator. So here you say this is your public add interface email meta annotation. That's what allowed you to put at email in your code. And you're saying constraint being it's validated by email validator class. And you define your email validator class essentially over here. So this is a class email validator implements, you define the constraint validator with genericized properly, saying the type is string, but the validation type is at email. It has an initialize method. The big chunk of the logic goes in is valid, where you actually get the value and you get the constraint validator context, and then you start playing around with it. Now this could be anything. You could check the format of the email. You could even talk to a database to validate if the email ID, user ID is registered, and things like that. So the idea is bean validation provides these level of constraints, and it has those capabilities. Why? Because the target says method, field, and parameter. So here, for example, now this particular one is designed for the field, but let me show you an example of a method level as well, the class level actually. So for example, here I have add check user 1. I just specified on my class itself. So add check user, in my is valid, then I'm defining, I will be getting an instance of a user class, and then from the user so it all depends upon what you have defined it for. Our previous validator constraint here, it says the type is string. All you would say is email, comma, user being a POJO class. So whatever you define the type, those all types you're going to start getting it here basically. So in this case, my constraint would look like emails, comma, user, or whatever, user, comma, user, or check user 1, comma, user. Then you get an instance of the user, and then with the user you start playing around. Maybe user has multiple fields that you want to validate, and how you want to validate. That logic goes in your annotation. There's no XML here. Well, effectively that still gets mapped to your POJO class though.
Correct. So let's talk in terms of XML. So does it have to be the parent of the XML, or it can be anywhere in the XML?
No, what's the need for? We have to keep it format independent. Remember, XML is just one type. It's just one representation of the resource. Right, it could be JSON as well. It could be text as well. So that's the reason it's important to ignore that, or actually realize the format independence. That's the reason it's important to talk in terms of the Java itself, that in terms of class user, what you do is check user 1, and that annotation is not being serialized on the wire. So what happens is whatever your type is, that gets serialized to Java, and that's when the annotation is being applied to it. So in this case, all I'm saying is, so on the method I'm saying register user 1 at valid, and valid is a standard annotation. It says user, so let me apply this annotation over here. Or I could also apply additional annotations, say add check user 2, if you want to do some additional validation in terms of where the user is coming from. Let's take a look at async. So async, the thought process as I explained earlier over there is, if your resources on the server side are going to do some sort of file I/O or database access, which is going to run long, so you don't want your thread to be occupied. Those are all basically borrowed threads. So you let them run free. So you just take the request, suspend it while the external action is happening, and then when the response is ready, then you return the response back to the client. Okay, so the design pattern really here is suspend and resume. That's the typical design pattern. And the goal over here is to definitely leverage the Servlet 3.x or Servlet 3.0 async support wherever it comes out. So let's take a look at the code again. So here I have my public class resource. This is the path where it's being exposed, so nothing special over there. All I'm doing is injecting an execution context over here. Just saying add context private execution context. Now this is my public void long running op. This is my method over here. I'm doing a executor's new single thread executor. Not the right way of doing things. We should really be doing concurrency utilities when they become available. But effectively, what I'm doing is I know this is going to be my long running thread. So I just spin a new thread as soon as I enter the method, and then this is the code that gets executed, and then here I say context.suspend. Okay, so this is running parallelly. It sleeps for 10 seconds, just a dumb logic, but just sleeps for 10 seconds. But the idea is, as soon as I enter my method, I suspend. This thread is free. This is running in a separate thread. Whenever this thread finishes, it says context.resume, and the response is returned back to the client. So that's my server-side asynchrony. Now, instead of doing context.suspend, I can also say, you know what? Hey, all I have in my method is just the stuff that needs to run in a separate thread. So I can add a add suspend annotation over there. Let's see how it's going to look like on the client side. So on the client side, this is the API. So here I'm going to just use my standard builder pattern, client.target, build my request. Then on the target, I say I'm going to explicitly call it async. Now, one thing to realize is the server-side asynchrony and the client-side asynchrony are independent. You can use one, either or both. That's the idea. Okay. So on the client side, coming back, so target.request, I'm explicitly calling async. Then I say get, and all I say is invocation callback. So I just set up a callback over there, and the invocation callback has a couple of methods, actually more. I'm just showing two: complete and failed. So complete is what's going to give you the actual response, and failed is going to give you the actual cause of the exception, what has triggered the error. Right. And I think another important part to realize over here is this, the request. So when you say async, this really gives you back a future object, which is a standard JDK 1.6 concurrency object. On handle, which is my future object. On there, you can actually monitor the progress. Is the request being processed? Is it being done? Or if not done, if you have waited too long, you can actually even cancel the request. No, if the connection is closed, then there's a separate request altogether. It's not a commit where you're pushing the response back from the server. So the connection stays open, but the threads are running free. The asynchrony is all about the server side threads maintaining those resources. Okay, let's talk a little bit about Hypermedia. So HttpOS is the hardest pronunciation. How do people come up with these acronyms? Hypermedia as the engine of app state. It defines one of the REST principles, basically, that everything that you need for a RESTful architecture is within the RESTful representation itself. So for example, you say, give me a representation of, my request is, send me a list of employees. Okay, you get a bunch of JSON with a list of employees over there. Then what you want to do is click or extract worst employee and say, give me more details about it. Then you say, okay, you know what, I'm going to give a bonus to that employee. And then you make more requests. So the idea is everything that you want to do as part of the request response communication, all that information is available to you within the request or the response itself. But you should still have the need to, or ability at least, to extract the request or extract the response and do the right thing on it. And there are two types of links, basically. in order, as HttpOS says, structural and the transition links. Now, in terms of structural, is the one that I explained, wherein you can say, you know what, this is how my this is my complete request right here, or my response. In my response, I have complete URLs. These are my structural links, which actually goes in the body. Transitional links are, as a matter of fact, goes up in the headers most of the time, wherein you're saying, okay, this is my request, and I'm going to do something with it. Say rel equals ship. I'm going to just ship the order, for example. Now, as part of JAX-RS 2.0, again, one of the features that we have been talking about and is still up for debate, structural links are not going to be supported because that requires somewhat extensive or rework in JAX-B. But transitional links are something that we are supporting pretty much right away. Yes, this is sort of your response right here. So in the response, you have so you said, okay, show me the list of customers. So you want to do something on the customers. So you will have to extract it from the body response and then do something on it. So how we expect the transitional links to work? On the server side, you will have a response. You're using the generic pattern here. You're saying response is there. On the response, I'm going to build a link. And this is a transitional link, which goes in the headers in this case for you. So you say ship, and you assign it a symbolic name over here. On the client side, you invoke the request or invoke the resource. Then you say on the order, which is your response, you say get me the link. And this is the same symbolic name that you're using. And then you process it accordingly. So that's a fairly straightforward representation of how we're going to do structural links. Right. Right. No, the structural link is going to be part of header. The transitional links are part of the body. Right. I'm sorry, the other way around. The transitional links are part of the header. The structural links are part of the body. And there is some support for structural links already in JAX-RS 1.1. It just requires way too much work on your side. Because I tried playing around with linking of the resources. It wasn't very intuitive, actually. The whole focus over here is most of the features I'm talking about, they exist in the vendor's implementation in a proprietary way. Let's provide a standard wrapper on that and do it the right way. Let's talk about connection negotiation. So how does the connection negotiation work today? Let's say I have a resource, and here I'm saying at produces, I'm spitting out two types. On the client side, what you're saying is, get me this request, and then my accept header says text/star. And I'm saying Q equals 1. That means the priority is 1. So on the server side, you come, you say, okay, client has says text/star. I spit out both plain and HTML. What should I do? Server is free. It can send plain or HTML. So client will be happy, but the response could be inconsistent across multiple implementations. You may optimize something based upon which is not specified in the contract. That's not the right thing to do, though. So the idea is to make it a little bit more explicit, or at least be more predictable from the server side. So just the way you specify the priority on the client side in the accept header, we are saying you could set the priority on the server side as well. So for example, with @produces clause, you could say this text plain has a priority of 0.5, HTML has a priority of 0.75. So in this case, say client is still saying the same thing, text/star. So my preferred type is going to be text/HTML. I'm going to return back. So the idea is you can rely that when a request is coming back from a server, it's always the same. Some other topics under consideration are better integration with JSR 330, which is CDI and context and dependency injection. So, and some folks are even talking about a higher level client API. And what that means is, think about when you do SOAP-based web service invocation, where you have, you take the WSDL, you generate the stubs, and you have the state baked in, and then you say, just go fire. So they're talking about, that API that you've introduced is not good enough. I want to have, just the way you have WSDL, we also have WADL for a RESTful web service. They're saying, take the model, generate my stubs for my RESTful web service, and I should be able to invoke it. So those are still being discussed. All right, so just some quick links for you guys. JSR page is this. That's where your early drafts are available. This is where you can actually contribute. If you have any specific use cases, file the issues for them, and they will be looked at. And all the discussions are forwarded to this user areas. All right.